Hello everyone, I am Monika Bhushan and today we are starting lecture number 8 of Power Series Solution. So in today's class we are going to find the expressions of Legendre polynomials for different values of n. Okay, so you can see that I have listed down P0x, P1x till P5x because these are very commonly asked in exams. So these are the Legendre polynomials, right? We have covered these all things. Even in the last class, we had derived the Rodrigues formula, correct? And today's class, we are going to see the use of Rodrigues formula. We will be putting different values of n, okay, in this Rodrigues formula, and then we will find these all expressions. So that only we are going to start with, okay. So here is the statement that using Rodrigues formula obtain expressions for P0x till P5x, and then we will be finding out the expressions x square, x cube, x4, x5 in terms of Legendre polynomials. Okay, so before that we will first try to get these all values and then we will come to this part. Okay, so in this respect Rodrigues formula is very helpful because in Legendre's polynomial, if different values of n are given, right? So Legendre polynomial is what? Pnx, correct? And we know that when x is 1, so the value will be 1. So those all things we have covered. But for different values of n, it will be very lengthy if we are not using Rodrigues formula to get the expressions. So we will be using this formula and then we'll see that how things are happening. Okay, so here we are starting, right? We have seen, we have covered it. This is nothing but my Rodrigues formula. So Rodrigues formula says what? That Pnx is nothing but 1 by 2 to the power n into factorial n into dn by dxn x square minus 1 to the power n. What does it mean? This says that this is nothing but x square minus 1 to the power n. Okay, so x square minus 1 to the power n, we are finding out nth derivative of it. Okay, and then we are just multiplying this constant with it. So the constant is 1 by 2 to the power n into factorial n, and the value of n is given to us, right? So if it is my p naught x, right here, if it is my p naught x, that means my n is 1, n is 0. If it is my p1 x, that means my n is 1, and so on. Okay, now what we are going to start with? We are going to start with p naught x. In this case, what I'll do? I'll put the value of n 0, right? 1 by 2 to the power 0 into 0 factorial, okay, into d 0 by dx 0, x square minus 1 to the power 0 equals 1. How this is 1, that we will be seeing. But before that, this is looking little fishy, correct? Because we always see that d by dx of something, some function, right? If we see d by dx of any function, suppose I'm just saying that this is your x square, so we know that this is nothing but we are finding the derivative one time of x square. And if we see that d2 by dx square of something, of suppose x square, that means what? We are finding out d by dx of d by dx of x square, right? That means twice we are differentiating it, and so on. And then here what we do? We find nth time derivative. We keep on doing it till n time, and then we get the whatever the required answer is there. But what does it mean? This usually we don't see d0 by dx0, correct? So this is actually nothing but if we are finding out 0th derivative of a function, right? This is nothing but a function. What is the function? Function is x square minus 1 to the power 0. This is something on which we are finding out d0 by dx0. Okay, that means 0th derivative of this function we are finding out. So 0th derivative of a function is basically the function itself. Okay, so this, if you will just focus on this part, this is nothing but the function itself, right? So the function is x square minus 1 to the power 0, and anything which has power 0 is nothing but 1. That means this complete term is giving me answer 1 only, and this makes sense also, right? If we differentiate the function 0th time, that means we just have the same function that we started with, because we have not done anything to change it, correct? So we got the same function, and this same function is actually giving me 1. And then if I'm just going to multiply 1 here, if 2 to the 1 by 2 to the power 0 factorial 0, and I'm multiplying 1 here, right? So we know that this is nothing but 1 into factorial 0 gives me how much? 1, right? Factorial 0 is also 1, factorial 1 is also 1. So finally I got 1 here. So P naught x is 1 that we got. Fine. Now we are going to deal with P1x. Okay, so to get P1x, the same thing we are going to follow, right? This is nothing but n, I am just substituting with 1. 1 by 2 to the power 1 into factorial 1 into d by dx of x square minus 1 to the power 1. And then what we will be getting here? So this is quite easy, right? This term, if you are finding out, so d by dx of x square will give you how much? It is going to give you 2x, and this is constant, so it will give you 0. So this is 2x. 2x you are going to multiply with 1 by 2 to the power 1. So this is nothing but x. So we got easily that my P1x is x only. Okay. Now, what is P2x? So same process, P2x, that means I'm just replacing n with 2. 1 by 2 square into factorial 2 into d2 by dx square of this function. This is what? This is x square minus 1 whole square. So if I'm just focusing on d2 by dx square of x square minus 1 whole square, I can write it in this fashion also. This is nothing but what? D by dx of x square minus 1 whole square, correct? So that means you are finding out d by dx of what? So this is what? This is complete term. Now you just focus on d by dx of x square minus 1 whole square. This is 2 into x square minus 1 and then 2x, correct? And then finally this is nothing but d by dx of 4x into x square minus 1, or we can write down will be how much? D by dx of 4x cube minus d by dx of 4x. That means this is nothing but 12x square minus 4, correct? And the same thing, yes, we have got here also. Okay, so and then this is 1 by 8 from where we have got. This is 1 by 4 into 2, 8. Okay, this is one way to solve. The other way, what is done here, this is a minus b whole square is what? A square minus 2ab plus b square, and then we have found d2 by dx square of it. Okay, so anyway, this is the answer you are going to get will be same. Okay, so we got this is p2x, this much. Fine. Now we are going to find P3x. So for P3x, again we are replacing n with 3. So 1 by 2 to the power 3 into 3 factorial, and this time this is what? This is d3 by dx cube x square minus 1 to the power 3. Okay, so what we are going to start with? We are going to write down this. I'm just finding out d3 by dx cube of x square minus 1 to the power 3. I can say that I am finding out d by dx of d by dx of d by dx, right? Of x square minus 1 to the power 3, right? So we can write it what? d2 by dx square is present here, and this is 3 into x square minus 1 whole square and then 2x, or we can say this is nothing but 6x and then x square minus 1 whole square. That means d2 by dx square of, this is what? 6x into a minus b whole square will give you a square and then plus b square minus 2ab. Okay, and then d2 by dx square of 6x to the power 5 plus 6x minus 12x cube, and then one time d by dx if I am finding out, so it will be what? D by dx of this complete term. Okay, that means this is what? D by dx of what? This is 30 x to the power 4 plus 6, then minus 36 x square, right? And then finally d by dx of this complete term will give you how much? This will be 120x cube, and then this will be 0, so it will be nothing but minus 72x. Fine, this is 120x cube minus 72x, and then this is written here, and then I'm going to divide it with 48, correct? No, because this is 8 into 6. So same thing we have got here also. Okay, this is again one way to solve. The other way which is present here is what I am doing here. This is nothing but a minus b whole cube. So I am writing down the formula of, if I am writing down the formula here, a minus b whole cube will give you how much? A cube minus b cube minus 3ab a minus b. Okay, and the same way, so this will be your x to the power 6 and so on. So you are just expanding using this formula, and then this complete term you are going to find 3 times derivative. Okay, so if it was your a plus b whole cube, so everything was plus. Suppose a plus b whole cube, so everything here will be plus. If it is minus, everything will be minus. Okay, but we will be seeing one more simple method using binomial method, right? We are going to solve this p3x, p4x, p5x and so on, right? Because that will be much easier. Rather than going into these details, we will be just putting into the formula and then we'll get the answer. So the binomial method we will be applying in finding of p4x. So if we start p4x, so the same thing, right? 2 to the power 4, like 1 by 2 to the power 4, factorial 4, d4 by dx4 x square minus 1 to the power 4. So finding 4 times derivative will be much tiring and time consuming. So we will be using binomial expansion first thing, and the second thing we will be, we have one formula, right? For that, this is the formula is nothing but dn by dxn. That means nth time if you are finding out derivative of x to the power m, so we have one ready-made formula for that also, that we are going to see here. So first thing is, see why we are using binomial, because we have to use this formula. We want to use this formula for easy calculation. The formula is what? Nth derivative if I am finding of x to the power m, that means dn by dxn of x to the power m. Okay, so it will be how much? It is nothing but factorial m divided by m minus n factorial. So in that case, m should be greater than n. Okay, then we will be using this formula. Okay, but this is, if you see the function here, the function is not only x to the power m, right? X square or x8 or something is not only there. The function is x square minus 1 to the power 4. So first we should simplify it with the respect of, right, in this form. So dn by dxn x to the power m. So to get into this form, that form will be present here, we are going to use binomial theorem so that this function will be simplified into this expanded form, and then easily we can use this formula here. In one line only we will be getting the answer, right? So if it is x square minus 1 to the power 4, so for that we are using binomial theorem. This binomial theorem we know, right? This is nothing but x minus a to the power n is how much? X to the power n minus nc1 x to the power n minus 1 a to the power 1 if it is 1, so this power has 1. If nc2, so a2, and if it is a2, so it will be completely this plus this should be n, so it will be n minus 2. Similarly nc3, if nc3, so a to the power 3, and completely that this thing should be n, so this will be n minus 3 and so on, correct? So, and this is nothing but your nc0 and this is your nc1. Okay, so these things we know, right? So if it is x minus a to the power n, so alternate plus minus will be present in the series. If it was your x plus a to the power n, so all terms were your plus, only this will be the difference which we have to actually understand, right? Okay, so we are going to write down in this form. So this is what? X square minus 1 to the power 4. The standard form is what? The standard form is x minus a to the power n. Okay, so x, if I'll write down here y, because y will be your x square. So in this case, it will be how much? This will be your nc0, and then nc0 xn minus nc1 xn minus 1 a to the power 1. Using binomial expansion, we have expanded this term also, right? And then we got this much. Okay, and then further we are just going to use this formula. So here we got this formula. The formula says that this is what the constant was present. So the formula is what? So since it was your x to the power 8, so here the first term will be how much? First term will be your since m is my 8, okay, and m is 8 and n is 4. Why? Because my right now what I am working on, d4 by dx4 x to the power 8. This is only my first term, correct? No? It will be factorial m, that means factorial 8 divided by m minus n factorial. Okay, so that means factorial 8 by factorial 4 and then x to the power m minus n, that means 8 minus 4, that is 4. So you can see here factorial 8 by factorial 4 x to the power 4. And similarly we are going to apply the same thing on these terms also, correct? So finally we got here that this much. After simplification we got my p4x is this much, 1 by 8 into 35x to the power 4 minus 30x square plus 3. If you will notice down, if it is your p4x, so your maximum power of x will be x to the power 4. If you have found p3x, maximum power of x will be x cube. If it is your p2x, so maximum power of x will be 2. Okay, no? If it is p1x, so it will be 1. p0x, it will be x to the power 0, which will be 1. Okay, now finally the same method we have followed to find p5x also, right? p5x also. So we want to use this formula. The formula is what? dn by dxn x to the power m, right? So but to get into this form, what I need to have? I need to have x to the power m form. The form is x square minus 1 to the power m or n, whatever. So to solve it, what we are going to use? First we are going to apply the binomial expansion, and then we have got, after applying binomial method, we got this term, and then finally we are just going to apply this formula, and then we got, after simplification, this much. This is what p5x is 1 by 8, 63x to the power 5. See, this is 5 if it is your p5x, minus 70x cube plus 15x. Okay, so if we got till p5, so further what we can now do here is we now express x square, x cube, x4, x5 in terms of Legendre polynomial. In form of Legendre polynomial, that means what? You need to write down x square in terms of something like p and x kind of thing. So each and every term should be containing p and x. Different values of n will be there, obviously. So if I am going to find out what is my x square expressed in terms of Legendre polynomial, so for that what I'm going to start with, I'm going to write down what just now we have done, right? So this is p2x is half 3x square minus 1. Or I can do here, right? This is 2 p2x equals 3x square minus 1. Here nothing we have done, correct? After that, this is 3x square equals 1 plus 2 p2x. And what I need to write down x square in terms of Legendre polynomial. But this second term is okay. Why? Because second term contains something with your Legendre polynomial, correct? No, but here this is 1. But we know that p naught x is 1. Just now we have said that p naught x is 1. So instead of 1, we will be writing down p naught x. Okay. So we have written down p naught x plus 2 p2x, and then since 3 was there, so finally x square will be 1 by 3 p naught x plus 2 by 3 p2x. Okay. Now we are going to find x cube in terms of Legendre polynomial. So we know p3x is 1 by 2 5x cube minus 3x. So this term x cube we want to write down in terms of Legendre polynomial. So before we will be simplifying it here, right? 2p3x is nothing but 5x cube minus 3x, or we can say that 5x cube, we are taking it into the left hand side because we want to know p3x in terms of Legendre polynomial. So it will be your 2p3x plus 3x. Okay, so this is your 3x, but x is, this term is okay. Why? Because this term already contains Legendre polynomial. This x we are going to replace with p1x, because we just now came to know that p1x is nothing but x. Written down p1x here, and then finally 5 has gone down, so so x cube is this much. Okay, find x to the power 4 in terms of Legendre polynomial. So we have to start with writing down p4x. This is how much the expression of p4x we have written down. Okay, and then finally adjustment has been done, and then left hand side we have taken x to the power 4, because this only I am interested in, correct? So this term is okay, but what about these two terms? Even this 3 into 1 I can use. Even this is your x square. Just now we discussed that if it is your x square, so better represent it with your p2x form, because p2x, the highest power will be your x square. So for that reason only we have written down here this after simplification, and then finally just we have written down this is your x to the power 4. If it is your only 1, so this is nothing but your p naught x. Okay, divided by 35 will give you 1 by 5, and so all terms contains Legendre polynomial. All terms contain Legendre polynomial. So here also we got it. Similarly for p5, same thing we are finding out. If I have to find x to the power 5 in terms of Legendre polynomial, so I have to write down p5x. Okay, and then after writing down this expression, we have just simplified here, and then taken in the left hand side x to the power 5. This term is okay, but what about this term and what about this term? So if it is your x cube, that means I'm going to write down in the form of p3x. Okay, so x cube in terms of p3x I'm going to write down. If it is only x, that means x power 1, so I'm going to write down x in terms of my p1x. Okay, so after doing all those replacement, we have got this term. Okay, and then finally we have got that all terms actually contain p5, p3, p1, whatever. That means each and every term has Legendre polynomial. So finally we got what is my x to the power 5 in terms of Legendre polynomial. Okay, so if you find this class useful, please like and subscribe my channel. Thank you.